So you've got a basic idea how to talk about bones. Let's talk about the bones specifically of the lower limb. Firstly, we've got the hip bone, or the pelvis. This is made out of 3 bones. We've got the ILIUM, which is this big flat bone. We've got the pubic bone, which is a smaller flat bone. Around the back here, we've got the ischium, which is again a smaller flat bone. These 3 bones are fused together, and we call that the innominate bone, which is the biggest bone of the pelvis. The pelvis itself is also comprised of this bone at the back, which is called the sacrum. You've covered other types of joints, and we can see that these 2 joints at the front and the back of the pelvis are fibrous joints. They don't move very much. We want stability from them. So that's our foundation, our strength of our lower limb, attaching it to the body. So that's the bony pelvis. But that's obviously attached to the lower limb. We've got these long bones of the lower limb. To talk about those, we need a disarticulated limb. Here's our disarticulated limb, still attached to our bony pelvis. And we've got various bones of this. We've got the long bone of the thigh, called the femur. We've got a ball and socket joint at one end and a hinge joint at the far end. Specific parts about this femur are this knobbly bit at the top. We call this the greater trochanter, where we've got quite a lot of muscles from the buttocks coming down and attaching onto this. These are big, powerful muscles, so therefore it's pulling a big attachment onto it. We've got a smaller lump here, which is the lesser trochanter. Again, you've got slightly smaller muscles coming around and attaching onto this, but again stabilising it. You'll notice that the ball socket at the end has a neck going down to the shaft. And this is the neck of the femur. This allows the leg, or the femur, to be off at a slight angle. If you'll notice that this is not going vertically downwards, it's going slightly towards the midline. And that's so that when we walk, we can keep our centre of gravity underneath our middle part rather than out towards one side. So those are the bones of the femur going down towards the knee. At the knee joint, we can see the femur has splayed out a bit. It's going wider so that we can spread our load over the knee joint itself. And we call these the condyles, one on the medial side and one on the lateral side. It's got a large articular surface here. It's also got some attachments, so muscles and ligaments can attach on the side of the condyles. So we come down to the knee joint. The femur is articulating with the tibia, which is this long bone which goes down to the foot. It's also articulating with this joint, this bone at the front of the knee joint, which is the patella. These 3 joints form a nice hinge joint. Again, we've got a widening of the tibia to allow a greater surface area, so we've got less pressure points on our bones, and it can articulate with this broad surface of the femur. If we look at the inside of the patella, the undersurface, we can see that's got a nice smooth articular surface as well, which can articulate with a smooth surface on the femur as it's going backwards and forwards. Special parts about the tibia is we notice just below the patella we've got a tuberosity, and we call this the tibial tuberosity, another fancy word for a lump. And that's because these big powerful muscles are coming down the front, attaching the patella and going on to attach to the tibial tuberosity on the top of the tibia. Those keen-eyed students of yours will notice that there's actually two bones in the lower leg. We call this part of the lower limb the leg, and we've got this other bone here which isn't very big really, it's quite weedy. You can see all the weight bearing part is going to be going down predominantly the tibia. This bone next door to it, the fibula, is really just a bone there to give lots of muscle attachments to. It's not bearing any weight down to the foot. Coming down to the foot, we can see that the tibia and the fibula are articulating at the ankle joint, allowing the ankle to move up and down, but also from side to side and rotate slightly. Within the foot itself, we've got several short bones, and we call these the tarsal bones. And then we've got some more long bones further onto the foot, and we call those the metatarsals. These bones allow the foot to adapt to the surface and shape which that foot is walking upon. So it can rotate slightly, but also it can curl over a surface. But if you look at those, they're still quite chunky, quite firm bones, because again, it's got to bear the whole of our weight with each step. So to wrap that up, think about the lower limb as three flat bones in the pelvis to join it to the body, a long bone in the femur with a ball and socket joint at one end and a hinge joint at the other, two bones in the leg, one really big strong one, the tibia, to bear the weight, the other small one to attach lots of muscles onto, which is the fibula. Then within the foot we've got some nice small bones together to allow the ankle joint to stabilise the foot, but also give some movement, and some longer thinner bones in the foot itself. Thanks very much.